The Creative College represents one of the top international schools in the UK, accommodating more than 1,700 students. It is not just a place for students to learn, it is a place where they can be creative, productive, and achieve excellence. The project is located in Bristol, southwest UK, with an area of 100,000 meters square. Analyzing the detailed weather, wind, and solar conditions of the site, we started from the most important function, which is the class, facing a north-south orientation, creating a module unit of that class and spreading to creating a wall for the student with all the needed function. These modules were then connected with the landscape and the main courtyard, joining all the functions together around one centralized heart space for the whole school. The role of the Creative College is not just exceptional on students and teachers. It helps the surrounding community by providing its facilities in the summertime, with a separate entrance to its sport and theatres facilities. With a built-up surface and landscape area, there is a space for future expansion with the possibility of putting 2 more modules.
The main objective was to create a space which is safe to use, enjoyable by helping students to socialize and communicate better, and bright by making the most efficient use of the outside sunlight, and helping the students to flourish and to be innovative, and making it comfortable by the use of the best suitable colors for schools. Green for improving efficiency and focus of the students. Light blue for making it more relaxing, calming, and friendly. Yellow for lifting their moods.
The design is built on 3 main environmental objectives: reduced energy demand and consumption, reduced heat gains, and efficient renewable resources. Building energy consumption was reduced by creating a well-insulated fabric and maximize natural ventilation. The use of cross-laminated timber has significant environmental impact in comparison with steel and concrete, which can reduce the CO2 by half. CLT also have great thermal ability and can be recycled and reused. Besides, the embodied carbon from transportation has been reduced due to the presence of the manufacturer being close to the site.
In terms of daylighting, the great height for the windows and the use of light shelves allowed more reflected light into the ceiling, distributing it to the whole space. In addition, the corridor's skylight connects students more with the outside nature and allow more light into the class. Vertical louvers were used with an automatic control in relation to the time and amount of light spotted on that space. Not to mention the sociable gathering areas with their use of skylight and trees, which helped reflecting more light into the space, and the angle of the wall helped letting more light inside.
Minimizing the heat gain in the building was achieved by a ventilation method inspired by a kiln, which is a thermally insulated chamber. The method of passive ventilation uses natural air movement and pressure differences to both passively cool and ventilate the building. Thermal-labyrinth ventilation system uses geothermal energy to condition outdoor air. It can cool and heat up to 13% of the air. It also acts as a heating, ventilation, and air conditioning system all in one.
A significant area of the roof was covered with green photosynthesis plants, which helped in lowering the ambient temperature, reducing the heat island effect, and improving the air quality with purifying the air by more than 30%. It also provides rainwater management, preventing runoff up to 5 mm. This water is harvested for use in toilets. And last but not least, they have a longer lifespan than standard roofs.
In terms of renewable energy use, PV panels are used on rooftops where there is no obstruction facing the south orientation. They are elevated at 13 degrees for maintaining their cleanliness in order to operate efficiently.
Another renewable resource is the ground pumps. The water that is circulated through the ground loop can also be used by the cooling distribution system within the building. They form an efficient solution for seasonal storage to deliver both heating and cooling. They have lower maintenance and running costs, less noise, and longer lifespan. Furthermore, they provide more than 50% carbon saving in comparison with gas and other boilers.
This design has provided a place where students, teachers, parents, and even the community to live, work, and enjoy for a substantial part of their lives. The implemented strategies will enable students to grow and learn in the fullest sense of a simulating and adaptable learning environment by providing spatial layout, energy efficiency, and the provision of a suitable indoor environmental quality. All this will eventually encourage them actively to learn through and act positively towards the environment around them.